So for this weekend's homework, you are in search of an absolute max or an absolute min, and you know what it is, but we're in pursuit of really a method that we can use to find that. And the one thing that we talked about in class is that you know that if you have absolute extrema, it's only going to occur at either an endpoint or a critical value. So our one way of doing this is to actually find the endpoints and the critical values and kind of have a little competition. So if we're going to look at question number 2, well, let's see. We have our endpoints, and in fact, I'm going to take care of those right now. I know if I plug a 1 in, that's going to give us a 3 over, let's see, square root of 5, whatever that is. And if I plug a negative 1 in fact, I know this is an odd function. I can tell that, so that's going to give me negative 3 over the square root of 5. And then we need to find our critical values. So we need to take the derivative, no way about that. You know that we need to use the quotient rule. And also notice how clearly I'm doing this. So anyone reading this is going to know sort of what my reasoning is. I'm labeling my first derivative of the top times the bottom, minus the derivative of the bottom. A little chain rule there, times the top, all over the bottom squared, which is just going to give me 4x squared plus 1. One thing I'm going to notice is I'm looking for where my derivative is either equal to 0 or undefined. And I know the denominator is never going to be equal to 0. So this derivative is never undefined. But for the top, that's another problem. And let's see what I am going to do. This becomes a little pain in the neck. I'm going to multiply top and bottom by, I'm going to try to get rid of this, to sort this out a little bit. So I'll multiply top and bottom by 4x squared plus 1 to the positive 1/2, which will leave me with, when I distribute that, I'll have 3 times just 4x squared plus 1 to the 1, minus, I'm going to cancel the 2 into the 8, so I'm going to have 12x squared, and then those will cancel out, and then in our denominator we're going to have 4x squared plus 1 to the 3/2. But then when I distribute this, we're going to have 12x squared plus 3 minus 12x squared. So already I'm seeing that the numerator is never going to equal 0. So the only two elements in the competition are what's going on at the end point. The other thing I'm going to say, though, is that I know that this is I always knew this was an odd function. I know that this goes from -1 to 1, whatever number this is. I know it goes through the origin. The other thing I know is that the derivative that I have is always positive, right? It's always 3 over some positive number. So I know that this is always increasing. So my absolute minimum, right, I'm going to say the absolute minimum value of the function is -3 over square root of 5, and it happens at x equals -1. And the absolute max is 3 over square root of 5, and it happens at x is equal to +1. And if we were going to graph this over -infinity to infinity, well, we've just acknowledged the fact that the first derivative is always positive. So I don't know really what this looks like, but I know that the function is always going to be increasing. So therefore, I'm not going to have any absolute max or absolute min. And what I could say is that the limit as x approaches infinity, right? I can't plug in infinity, but I can find the limit as x approaches infinity of 3x over root 4x squared plus 1. And in fact, this is infinity over infinity, but I'm going to write this as the square root of 9x squared over 4x squared plus 1. And this is going to give me, let's see, the plus 1 I can ignore. And so this is going to give me 3/2. So in actuality, this is what this looks like. As x approaches infinity, I'm going to have a horizontal asymptote at y is equal to 3/2. And as we go to -infinity, another horizontal asymptote at y is equal to -3/2. So this is a bounded function, but nevertheless, we never acquire an absolute max or an absolute min.